Hello everyone, in this video we are going to take a look at a very interesting logarithmic integral. I equals integration of log of x plus 1 by log x power 2 dx. Here we are going to use two techniques. One is substitution and another one is integration by parts. So let's do both of those. The first thing I'm going to observe here is that I'm going to substitute this log of x with what? I'm going to take u equals log of x, which will imply e power u equals x. Differentiating on both sides, we have e power u du equals dx. Okay. Now that we have that, let's rewrite I. In this case, I equals integral of log. Since we have log x as u, this will become u plus 1 by log x. Again, we have substituted as u. So this will be u square. Now dx will be replaced with e power u du. Rearranging the terms, we have integral of e power u log u du plus e power u by u square du. Now let's take these one at a time. I am going to term this as my I1 and this as my I2. Now I1 equals integration of e power u log u du. I am going to rewrite it a little bit. I am going to write it as so. We'll see shortly why. I am going to take this as my p and this as my q. Now remember, in integration by parts we have integral of pq equals p integral q minus integral of p dash integral of q plus c. So using this formula, I am going to expand this. Log u integral of eu du minus differential of log u is 1 by u integral of eu du taken under the integral sign plus c. Now here we have integral of eu du as eu and log u minus here we have 1 by u e power u, okay, and plus constant. Okay, now we have to solve this. Now what I'm going to do is cheat a little bit. I'm going to take to our original equation I equals I1 plus I2. Yes, I have said that I will solve for I1 and I2 separately, but combining them we'll get something even more brilliant. So substitute these values. We have I1 as e power u log u minus 1 by u e power u taken under integral. We'll come to the constant later. Plus, what's the other one? E power u by u square taken under the integral sign, right? Now what I'm going to do is combine these two terms, e power u log u minus, or let's say I'm going to retain the sign, I'm going to take it as plus, I'm going to take e power u into minus 1 by u plus 1 by u square du. Okay. Now, if you have seen my previous video, you would know that if you had watched my previous video, you would know that integral of e power p into f of p plus f dash of p dp is e power p into f of p plus constant. Here we can observe that this entity looks eerily similar to our LHS here. So upon a closer look, what I'm going to do is that I'm going to take my f of p, or in this case should I say f of u, as minus 1 by u, which I can write it as minus u power minus 1, and in that case f dash of u would be equal to minus 1 because we are taking the power here, and u power minus 2. Minus minus gets cancelled, we have u power minus 2, which I will write as 1 by u squared. Now look at our left hand side. What do we have? E power u into our f of p is this minus u power minus 1 and f dash of u as u power minus 2 du. By this identity, we have this whole thing on the left hand side as e power u into what is f of p? Minus of u power minus 1 minus e power u by u. Substituting this value back into our original equation, we have I equals e power u log u plus this value we have gotten to be minus e power u by u. So let's take e power u outside and we will have log u minus 1 by u. Now remember, we had substituted u equals log x. So let's do a reverse substitution, which will bring us e power log x multiplied by what is log u? Log of x minus 1 by log x plus c. Now you know that e power log x is nothing but x, right? So that will become x into log of x minus 1 by log x plus c. Thank you for watching this video. See you in the next one. Take care. Bye bye.